Hello friends, welcome back to Learn Engineering with Mira. Today we will solve a problem on a typical roof truss. We will find out all the forces acting on members using method of joints. A quick tip to solve numerical really fast will be discussed in last section of the video. So keep watching till the end. This is a typical residential building where truss is used as part of the roofing system. And we want to find out forces acting on all the joints of this truss. So let's take one of the plain trusses and find out forces acting on all of its joints by method of joints. Let's give the joints some name for reference. Suppose length of these members is 2 meter and load of 1 kilonewton is acting on all the upper joints of truss due to the weight of roof. So let's begin. The first step in this method is to find out support reactions. Here at joint A, there is a hinge support which allows the rotation of member but do not allow horizontal or vertical movement. So there will be two reactions, RA in vertical direction and HA in horizontal direction. At joint E, truss is simply supported on wall which restricts the movement in vertical direction only. So there will be only one reaction, RE. Before we begin, let's remember the sign conventions we are going to use. Upward force will have a positive sign and force acting in downward direction will have a negative sign. Similarly, anti-clockwise moment will be positive while clockwise moment will be negative. I find this sign conventions convenient. You can alter it as per your choice. Now consider the free body diagram of the truss as a whole. For this, consider only the external forces and reactions and ignore the forces acting on members. Now, there are three equilibrium equations available to find out reactions. Summation of all horizontal forces must be 0, all vertical forces must be 0, and summation of moment should be 0. Here, sigma FH is 0, so HA is equals to 0 because there is no other horizontal force acting on the truss. Now, sigma FV is equals to 0. So forces in upward directions will be positive, so RA plus RE, and forces acting on joints A, B, C, D and E will be negative, so minus 5 is equals to 0. We don't know the value of RA or RE yet, so move to the next condition, that is sigma MA is equals to 0. We know that moment is force multiplied by distance. Suppose joint A is fixed and only RE is applied at joint E. It will rotate the truss in anti-clockwise direction. So we will have a positive sign. But for 1 kilonewton force at E, truss will rotate in clockwise direction. So it will have negative sign. Distance of both forces from A is 8 meter. So RE into 8 minus 1 into 8. Similarly, take moment of forces at joints D, C and B and summation of all these moments is equals to 0. So we get Re equals to 2.5 kilonewton. Put this value in above equation and we get Ra equals to 2.5 kilonewton too. To find out forces on joints, we will consider all the members as well as the internal forces acting in members. So next step is to locate directions of all the forces acting on joints. The direction of force can either be away from the joints, which indicates tension, or it can be towards the joint, which is compression. In given problem, no specifications for tensile or compressive forces are given. So we have to assume the directions of forces at each joint wherever a member is connected. Let's assume that all the forces are tensile in nature. Next step is to find magnitude of forces at one of the joints. To find out the forces acting on individual joints, we will use the equilibrium equations again. But here, for one particular joint, all the forces are meeting at a point, and so in moments equation, force into distance, distance is 0, and thus there is no point of considering the equation sigma m is equals to 0. So there are only two equilibrium equations. So first of all, select a joint where only two unknown forces are acting. Here, as we have already calculated the reactions, at joints A and E, there are only two unknown forces. All other joints have three or more unknown forces. So let's start with joint A. First, we have to find out angles all the inclined members at joint make with x or y axis. For joint A, AB is the only inclined member. So first find out angle. Let's say theta, it makes with x axis using trigonometric equation of tan theta. In right angle triangle ACG, opposite side CG is 2 meter and adjacent side AG is 4 meter. So angle theta we get is 26.56 degree. You can name the unknown forces like FAB, FAH, etc. Nearest joint A first and then joint at other end of member. Now drag force Ra, that is 2.5 kilonewton force and 1 kilonewton force along y-axis so that tails of all the forces meet at center. Components of force FAB would be FAB cos theta along x-axis and FAB sin theta along y-axis. Now sigma FH is equals to 0. So FAH plus FAB cos theta is equals to 0 as both forces are in same direction. We don't know any of the values yet, so let's solve second equation sigma FV is equals to 0. So FAB sin theta plus 2.5 minus 1 is equals to 0. The negative sign indicates that 1 kilonewton force is acting in opposite direction. Put theta is equals to 26.56 degree and we get FAB is equals to minus 3.35 kilonewton. Put this value in above equation and we get FAH is equals to 3 kilonewton. If the answer is positive, the assumed direction of force is correct, otherwise the opposite direction should be selected. So FAH is tensile force but FAB is compressive one. but for convenience, right now we will keep the directions as it is. Next step is to repeat step number 3 at all the remaining joints one by one. After calculating forces at joint A, we have two options, joint B and joint H. But both the joints have more than two unknown forces. Then which one is to select? So as we have already calculated FAB and FAH, forces on other side of the member will be exactly equal but in opposite direction to maintain equilibrium. Now at joint B, there are two unknown forces left, and at joint H, there are three unknown forces. So begin with joint B. Let's name all the forces. Again, first step is to find out angles all the inclined members make with either x or y axis. Here BA and BC are inclined members. Now we have already calculated this angle theta. This makes a Z shape, and so this angle is theta and this one is theta 2. So forces FBA and FBC makes theta angle to x-axis. Now drag 1 kilonewton force in downward direction so that all the forces are meeting at center. Components of force FBA are FBA cos theta and FBA sin theta, and components of FBC are FBC cos theta and FBC sin theta respectively along x and y axis. Now the first equilibrium condition is sigma FH is equals to 0. So we get this equation. Both forces are in opposite direction, so we'll have a negative sign. And as theta is same, we get FBC equals to FBA, that is minus 3.35 kilonewton as discussed earlier. Now sigma FV is equals to 0. So we get this equation. Here FBA is equals to FBC. So it will get cancelled and we get FBH is equals to minus 1 kilonewton. Repeat step number 4 for next joint. As we calculated FBC and FBH, forces at other ends of members will also have the same magnitude. And so now there are only two unknown forces, FHC and FHG, left at joint H. Let's first of all find out angle alpha inclined member HC make with x-axis. Again we will use trigonometric equation of tan alpha. Here for triangle HCG, the opposite side CG is 2 meter and adjacent side HG is also 2 meter. So alpha is equals to 45 degree. So components of force FHC along x and y axis are FHC cos 45 degree and FHC sin 45 degree respectively. Now sigma FH is equals to 0. So FHG plus FHC cos 45 minus 3 is equals to 0. And sigma FV is equals to 0. So FHC sin 45 minus 1 is equals to 0. So we get FHC is equals to 1.41 kilonewton. Put value in above equation and so FHG is equals to 2 kilonewton. Again repeat step 4 for next joint. As we calculated F at C and F at G, forces at other ends of members will also have the same magnitude. And so at joint G, now there are only two unknown forces, FGF and FGC left. Here there is no inclined member, so go straight to the force analysis. Now sigma FH is equals to 0. So FGF is equals to 2 kilonewton and sigma FV is equals to 0. So FGC is equals to 0. As FGC is equals to 0, opposite force at joint C will be 0 too. Now if you observe here, we have calculated the magnitude of forces of half of the truss. And as the given truss is symmetrical, that is the size and shape of members on opposite sides, angles and even the external forces acting are similar on both sides. So magnitude of forces acting at joints will be same too. You can directly write down the magnitudes like this or find it out individually one by same method as we discussed. By doing this, you can check whether your solved numerical is correct or not, as resultant magnitudes of forces must be equal to forces on opposite side. In last step, make a table showing name of members in first column, magnitude of forces and the direction, that is tension or compression, in last column. Members AB, BC, CD and DE all have same magnitude of force minus 3.35 kilonewton. Now as we have assumed that direction of all the forces is tension, negative value indicates compression. So simply remove the negative sign and write C for compression instead. Force in members AH and EF is 3 kilonewton, which is positive, so assumed direction tension is correct. Similarly, BH and DF have 1 kilonewton compressive force. HC and CF is 1.41 kilonewton tensile force. HG and FG have 2 kilonewton tensile force and CG is 0. At a certain joint, if there are only 3 members, out of which 2 are collinear and there is no external force, like joint G in our case, HG and GF are in same line, forces in both members will be equal and opposite. And the force in third member CG will be 0. But for same situation, if external force is acting on the joint, like in case of joint B, the collinear members BA and BC will have equal and opposite forces, but the force in third member will be equal to external force but in opposite direction.